The idea of 7a question 1 is to prove the formulas to you. And we do that by looking at this diagram here that's been set up for us. There's an alternative one as well, but this is the one they set up. And you've told a couple of angles here. If that's alpha minus beta and that's beta, clearly that angle there to there is alpha. And that means this one down here is 90 minus alpha. And in this right angled triangle here, if that's 90 minus alpha, then that one there is alpha. That one's 90 minus alpha again, which means this angle here is alpha as well. So we've got some angles sorted. Now what we're going to do is look at a number of triangles, one after the other. The first thing we're going to try and do is what A to B is. So A to B here is by looking at this triangle in the middle here. And in that triangle in the middle, we've got 1 there, and we've got beta here. And the adjacent side is the cos of beta. So this side here is the cos of beta, and the opposite side there is the sine of beta, on our right, sine of beta there. Look, we could go into more detail about that, but it's because there's a 1 on the hypotenuse, as we've got that. Now let's look at this triangle and this bit down here, and I want to figure out what the sine of alpha is here. And I'm also going to work out what the cos of alpha is here on this triangle. On this triangle, the sine of alpha is the opposite side, which is A to D, divided by the hypotenuse, which is cos beta. And the cos of alpha here is the adjacent side, this side here, BD, divided by the hypotenuse again, which is the cos of beta. And just by multiplying that up, I can get 2 useful pieces of algebra. BD is equal to cos alpha times cos beta. And that's part B of the question. Part C says do the same thing again, but now look at this triangle here. This little triangle here. And again, we want to find out what the sine of alpha is. The sine of alpha here is the opposite side, EB, divided by the hypotenuse, which this time is the sine of beta. And the cos of alpha here, the cos is the adjacent side, that's CE, divided by the hypotenuse, which is the sine of beta. And much like I did before, we're going to go EB, multiply that up. I've got sine alpha, sine beta this time, and CE is cos alpha, sine beta this time. And I'm going to need these 4 things in a second, so let's just highlight them, because we've got one last triangle to go. The last triangle we're looking in is this big one over here. And again, we've got a hypotenuse of 1 here. And so the side FA from there to there is just the cos of alpha minus beta. And the side FC there is the opposite. So it's the sine of alpha minus beta. But what you're supposed to notice is that F to A, there to there, is equal to these 2 things added together. That's E to B plus B to D. And E to B was that one, sine alpha, sine beta. And then I'm adding B to D is cos alpha, cos beta. And look, that is one of the rules that we've been trying to show. The other one is F to C. So F to C, actually, well, that's just there to there, isn't it? F to C, that's not the whole thing, but F to C is A to D, take away that bit there, C to E. And A to D is there, that's sine alpha, cos beta, minus C to E, that one there, cos alpha, sine beta. And so there's the other rule that you were trying to show.